Okay, so we're on worksheet 2-2 still. We're on question, you said 61 we're on? Okay, so they want all 6 trig functions, so more of the same type stuff, 3 more of these kind of longer questions and something that's a little bit different. So we're looking at number 61 on section 2-2. They give us negative 45 degrees, and again, if you want to save you a little bit of time, you can just write sine equals, technically that doesn't make sense, so you should say the sine of 45 degrees and so forth. But save you a little time. Cotangent, secant, and cosecant. And remember, I think we're gonna have our unit circle quiz next Tuesday. Online people that are gonna be watching this video, I'm not sure if you're taking your unit circle quiz next Wednesday or not, because aren't they taking the SATs Wednesday? Do you guys know about that? In the field house? Is that next Wednesday? Okay. So, I don't know. They're supposed to, whenever they're supposed to take quizzes, online kids are supposed to take quizzes. I was told they're supposed to take it in the field house, where they'll be socially distanced, but they can't because it's gonna be used for SAT. So I don't know yet. I have to check with the office, but I'll email those students and let them know. You guys are taking yours Tuesday though, either way, okay? So, we put it off long enough. And again, you either know it or you don't. Okay, so there's nowhere on your unit circle that says negative 45 degrees. Where do you think you're probably going to look at, though, for negative 45? I mean, you can use your unit circle even though it's not written on there.
315.
Yeah, 315 degrees. Okay, so maybe 45, if you want to picture it, 45 is right here, so negative 45 is right there. So it's 315 degrees, okay? And the sine at 315 degrees is negative radical 2 over 2. Your cosine is positive radical 2 over 2, and your tangent is negative 1. And again, we said this a bunch of times yesterday. We'll say it again, though. Where do we find cotangent, secant, and cosecant written at on a unit circle? We don't. You flip them. To find cotangent, you flip tangent. If you flip negative 1, it stays negative 1. For cosine, if you flip radical 2 over 2, I showed you a little shortcut. The reciprocal of a radical over that number is just the radical. It's radical 2. And this is going to be negative radical 2. So hopefully that wasn't too bad. Any question on that one? About number 63. 5 pi over 2. This would be a really short one. 5 pi over 2. Again, you don't see that written on unit circle. What I would encourage you to do when it's written as an improper fraction that's not on the unit circle, I would divide it out. 2 goes into 5, 2 with 1 left over, so 2.5 pi's. Okay? So where is 2.5 pi's going to be all the way around, and then another 90 degrees, another pi over 2. So you're going to look at pi over 2, okay? So it's all the way around and then another quarter turn to 90 degrees. So sine, cosine, and tangent, cotangent, secant, and cosecant. Okay, so the sine at 90 degrees, which is the same ending spot as 5 pi over 2, is 1. Our cosine is 0. Remember, it goes cosine sine. Okay? And our tangent is undefined. If for cosecant, if you flip sine, which is 1, you still get 1. Secant, you flip cosine, the reciprocal of 0 is undefined. Well, if tangent's undefined, cotangent's a reciprocal of undefined, which is 0, which, again, that's not really mathematically accurate. You can't flip a number that doesn't exist. But if 0's reciprocal is undefined, undefined reciprocal is 0. Hopefully that makes sense. That one wasn't too bad. This one's even easier. 65. 720 degrees. Where's that at in 2 words? Where would that be? 720 degrees. Where would that be located at? I think you should summarize it in 2 words. Coach Scholes tells you to run 720 degrees, 2 laps, twice around. Once around is 360, twice around 720. So you're twice around. Okay, so the sine, the cosine, and the tangent. Cotangent, secant, and the cosecant. Well, the sine is 0. Cosine at 0 or 360 or 720, whatever, is 1. Tangent is 0. Cosecant is undefined since sine is 0, and cotangent also is undefined because tangent is 0. Secant is reciprocal of 1, which is 1. Okay, any question on those? It's the same problem over and over and over for the most part. Okay, we crossed off 67 through 82. Okay? Now, I want to make sure you guys understand, when I give you that unit circle the second day of school, I want to be really clear. If you remember, unit circle, I draw this great big huge unit circle, okay? But this right here is one unit. I mean, normally, if we go back to middle school, if I told you, graph lines and stuff like that, you'd go like this, You'd have it look like this. And I used to draw the unit circle, it would look like that. And it looks really teeny tiny. Because here's one, here's negative one, here's one, here's negative one. I drew it so big because you had all that information you had to put in there, so I just blew it up, okay? So this is a unit circle, but we just blew it up right there. So just keep that in mind, okay? Why do I bring that up? Well, when you look at this one, they give you negative 3, 4 for number 83. We're on 83 now. They give you the point negative 3, 4. Is the point negative 3, 4 on the unit circle? Is that on the unit circle? There's no way it's on the unit circle. Because, if we think about this, I shouldn't have erased that. Here's my unit circle. My unit circle would have looked like this. The point negative 3, 4 is 1, 2, 3, and it's way beyond the unit circle. It's outside the unit circle, okay? Now, can we still use the unit circle? Well, kind of, but not really, okay? Because it's not on the unit circle, it's beyond it. So that only works. So what I want to make sure you understand is this, okay? Some students, if you're looking at the front of your unit circle, you might say that the sine is 4 and the cosine is negative 3, okay? No, okay? If you're going, well, I thought you said sine is the y value and cosine is the x value. That's what it says on a unit circle. What I said, I told you to write that down, but what I said when I told you to write it was x is cosine and y is sine on the unit circle. This point's not on the unit circle, it's beyond the unit circle, okay? So, how do we do, and not only that, there's no way that sine could be 4, okay? Any idea what's the biggest sine could ever get to? Any ideas? 1, why? It is unit, okay, what's the lowest it could get to? Not 0. Negative 1. Why negative 1? Where? I'm looking for a keyword. Ooh, sine. Down. Down 1 spot. Why could the biggest it ever be is positive 1? Not just because it's a unit circle, but up 1. What's the biggest cosine could be? 1, why? Right 1. What's the smallest cosine could be? Negative 1, left 1, okay? So, it can never be 4, it can never be negative 3, it's impossible, okay? So, students tend to struggle with this type of problem, okay? Here's what you do, listen really, really carefully, okay? If you have points that are on the unit circle, and up until now, everything we've done was on the unit circle. They even told us it was on the unit circle, okay? So, here's what you do. You draw a picture, and you don't need to be an artist, okay? I'm not very good at drawing, but I can still get through this, okay? So we draw a picture, and it's a very basic picture. First thing you do is you plot 0, 0, okay? Put a dot right there, 0, 0. And then you plot the point they give you. They give you the point negative 3, 4. So, go left 3, up 4. And put a dot at negative 3, 4. So you have your 2 dots, okay? And then connect them. So far, it shouldn't be too bad. And then what you're going to do, this is where it gets a little tricky, just a little bit, you got to listen real carefully here. You form a right triangle, and you always do it by connecting it to the x-axis, not the y-axis. So here's my x-axis. I'm going to drop it straight down. Do not connect it to the y-axis. You drop it straight down, okay? And we have a right triangle, okay? Now, we have what's called a reference angle. Our reference angle is the angle in the triangle coming out of 0, 0, okay? The angle coming out of 0, 0. Here's 0, 0, here's the angle. I'm going to label that theta, okay? Label that theta. Okay. Now, we need to label the lengths of that triangle. What is this length right here?
3.
It is 3. We're not going to label it 3 though. We're going to label it y, one word.
Left.
It's left. So we're going to label it -3. What's this length right here? 4. Are we going to label it 4 or +4?
Either way.
No, not either way. Why +4? Up. Okay? Now, to find the third side, I don't think I've said this in this class yet this year. To find this third side, I mean, we could use the Pythagorean theorem, a squared plus b squared is c squared. But, and this, forget about math right now. If you're a carpenter or something like that, they will flat out tell you this is something they use all the time. Okay, I'm not a carpenter, but I've talked to people that 3, 4, 5, okay? If you have a triangle of lengths 3, 4, and 5, that it's going to form a right triangle. It's gonna, okay? So if you're measuring things and it's 3, 4, and not 5, it's not a right triangle. It's not a right angle, okay? So if you want to label this, let's just label it 5. If you didn't know, now if this was like 7 and 8, we'd have to use the Pythagorean theorem. That's not a very nice. There's 2 triangles, definitely 2 triangles you really want to know, and that's 3, 4, 5. Another one's really nice to know is 5, 12, 13. 5, 12, 13, okay? So if I give you a triangle of length 5, there's other special right triangles. Those are pretty basic ones. I mean, 3, 4, 5, you can't forget that. That's easy. They count right in order. And then 5, 12, 13, okay? So, now watch real carefully right here, okay? We'll see how well you guys are listening. Let's say we didn't know that was 5. Let's say you forgot that, 3, 4, 5. You'd say a squared plus b squared equals c squared. You would say -3 squared plus 4 squared equals c squared. -3 squared is 9. 4 squared is 16 is c squared. 9 and 16 is 25, c squared. Then you square root it. And you get c is, if you remember from algebra 2, you're supposed to put a plus or minus radical, plus or minus 5. Okay, plus or minus 5. Now, let's backtrack right here. We'll see how well you guys are listening. You guys already said this is -3 because it's left. You said this was +4 because it's up. And everything's good so far. Is this 5 or -5? Short answer is it's 5. The hypotenuse is always positive. It's always positive, okay? Hypotenuse is always positive. And I hate doing this because it's kind of copping out. I'm kind of punting here. I like to explain why behind it. Here's my reason why. It's always positive because I said so, okay? It's not like I'm God and I can do whatever I want. It just always is. The hypotenuse is always positive because Mr. Cato said so. So in a little bit, when I say the hypotenuse is positive or negative, you'll say positive. I'll say why. You'll say because I said so, okay? So, and I don't make the rules. I'm just saying it always is. Okay, hypotenuse is always positive. All right, we're not done with this yet. And you don't need to look at this right now. What is sine? Not as what is the sign here. What is sine? Well, SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, okay? So the sine of this angle, and I don't know what the angle is. I have no idea. The best I could say, and Cassie did this the other day on a different problem, it's somewhere between 90 degrees and 180 degrees. I don't know, okay? And if you're sitting there going, well, that's a lot smaller than that. That's just our reference angle right there, okay? But, I mean, we're talking about going this far, okay? That's our reference angle. So sine is opposite of hypotenuse. So this is our angle. Opposite it is 4 over the hypotenuse is 5. Now, I'm not going to write the other 5 yet. You should be able to tell me immediately what cosecant is. 5 over 4. Just flip sign. Cosine is adjacent over hypotenuse. Adjacent is -3 over 5. Again, you should be able to tell me secant right now. Is it 5 over -3 or -5/3? It doesn't matter. The negative will go on the top or the bottom or the middle. It really doesn't matter. Okay, it doesn't matter where the negative is. And tangent, you could do sine over cosine, or you could do opposite 4 over adjacent -3. So -4/3. So cotangent is -3/4. So what's different about this question is this point wasn't on the unit circle. It was beyond the unit circle. What if it was inside the unit circle? You still do it the same way. That only works if it's on the unit circle. If it's not on the unit circle, draw a picture and fill in all the lengths, and then use SOHCAHTOA, okay? Students generally struggle with this, okay? So I'm going to tell you right now, there's going to be, on your first test, other than that unit circle quiz, there'll be questions like this. Not a lot, but there'll be a few. What stinks about this is there's only like 5 or 6 questions here. There's not that many of them, okay? I think students struggle with it because they don't get to practice at it because the assignment doesn't have that many questions. But again, the only difference is if it's not on the unit circle, draw a picture, fill in the information, use SOHCAHTOA. Okay, 85. Without drawing a picture, is 2 negative 3 on the unit circle or not? No, how come? Yeah, it's not between 1 and negative 1. 2 is way too big, negative 3 is way too small. Okay? It's beyond the unit circle, so we draw our picture. We have to point 2, negative 3, so right 2, down 3, put a dot, and put a dot at 0, 0. Okay? So we put a dot at 0, 0, and 2, negative 3. And then we connect the 2. And then how am I going to make my triangle? What am I going to do? Draw straight up. You always connect it to the x-axis. And it's not just a triangle, it's a right triangle. Okay? This length is 2. This length is negative 3, and it's positive 2 because it went right. And it's negative 3 because it went down. This is not a special triangle. Okay? This is going to be, you're going to have radicals in your answer here. That's okay. So, to find out what this is, we'll label this C or X or whatever you want. A squared plus B squared, so 2 squared plus negative 3 squared equals C squared. Again, or X squared or whatever, H squared, it doesn't matter, whatever you want to use. So we have 4 plus 9 is C squared. Add them together, you get 13 is C squared. Square root, you see is radical 13 plus or minus. Is it plus or is it minus? Why? Why? Because I said so. Radical 13, good answers. Hello? Uh-huh. Oh, okay. Beers, Bigelow, and Mitchell? Okay, yep, they'll be right there. Yep, bye. Okay, Beers, Bigelow, and Mitchell, your lunch is here, go get it.
That took a while. Jeez.
Hey, but it's gonna be nice and hot, I would hope. Better be.
Why not?
The soggy, I'll tell you that. I saw the lunches, they were pretty, look, they said it tasted good, but the bread was a little soggy, they said. Okay, so radical 13, positive radical 13. Okay, I'm gonna pause for just a second here while they're gone. We can come back and get these. How many we have? There's 85, 87, and 89. Okay, those aren't gonna take long. So first W's tonight, hopefully. I'll be here, but not watching you or anybody. I'm taking tickets over here for JV, I guess. So can I like look through the door, or will like the virus get me if I look through the door if I'm out in the cafeteria? Do you know? So.
Gotta take a chance, I guess.
I hear Everett's coming back this weekend. That's what.
Come back today.
Yeah, for the weekend. Yep. It was at.
Hope.
I think it was Hope. Yeah.
Jeff or something.
I honestly can't. Some of these. I mean, I thought it was Hope I was talking to. Some of you have taught several years. I've never had her, and
Yeah.
thought that was Hope Sly I was talking to. She's friends with Everett too. I didn't know that. She is sophomore, or junior.
Junior.
She's a junior. It's the first year I've had her. Huh.
Yep.
I had her dad and her mom.
Mm-hmm.
Her mom's
Tammy.
Tammy. Used to be Krantz, Chucky's sister.
Yep.
Yeah. So. Do you know?
Ron.
Oh, you know his name is Ron?
Yeah.
Okay, I didn't know if you know that. Everybody calls him Chucky though. So it was funny because who was it? Like a distant relative is his. I had a few years ago. I forget who it was. And I mentioned Chucky, and then I said Ronnie. She's like, "Who's that?" Like, that's Chucky. And she's a distant relative. She didn't realize that his real name wasn't Chucky. So why do they call him Chucky? He said that when he was younger, everybody thought he looked like Charlie Brown, so they called him Chucky. So
We just call him Chuck.
yeah. His boy, is he like a 6th grader now? The younger one?
Yeah, Blake.
Yeah. Did he wrestled all this summer, do you know?
Oh, yeah, I think so.
He's going to be really good.
Yeah.
I mean, athletic all the way around. He played baseball with my son for a couple of years, and that kid, anything, he could pretty much do, it looks like. Which I don't get, because Chucky he's into sports, but he wasn't,
He played basketball.
but he wasn't I mean, he was very average, and I don't think Tammy did anything, did she? She might have cheerleaded, I think.
She might
I
have.
don't think she did anything. So, but just kills me that I'm teaching kids. Well, yeah, I had your mom, but not your dad. Your dad, I think, missed. When did your dad graduate? 99? 98? 98? Yeah, I missed him by a few years. Your aunt I had, though, Tricia,
Mhm.
and uncle, Brian, right? Getting old. So, okay, we waited long enough. They're taking too long. Okay, so sine, cosine, tangent, cotangent, secant, and cosecant. Okay. So sine, now a reference angle is always, it's inside the triangle, coming out of the 90-degree angle, or coming out of the origin, coming out of 0, 0. Okay? So sine, this is theta, that's the angle we're talking about, is opposite -3 over radical 13, which is unacceptable. I'm going to write it down, though, because I'll tell you what, I'm going to find something before I find sine. I'm going to do cosecant right now. I'm going to flip this thing right now. Radical 13 over -3. But, let's go back here. We got to fix this, okay? Times radical 13, you're going to have -3 radical 13 over 13. I skipped a step there. Are we okay with that? That times the top and the bottom by radical 13. So that radical 13 just turns into regular 13. Cosine is the Zer angle adjacent to over radical 13. I'm going to find secant right now. It's radical 13 over 2. Times our radical 13, you're going to get 2 radical 13 over 13. And tangent, opposite, -3 over adjacent is 2, -3 over 2. Cotangent is -2 over 3. Okay. Those of you who just got here, we waited for a little bit, but you're a little behind. I'm going to leave number 85 on the board here. I want you guys just, I'll leave it up here. You guys, I don't want you guys trying to catch up and then you're missing other stuff. So just leave a space for 85 and we'll move on to 87. Just make sure I don't erase that. 87 will be an easy one. -2, -2. Again, this is not on the unit circle, but what I want you to understand is, even though it's beyond the unit circle, I mean, this one kind of is on the unit circle. It kind of is. Anybody know where we'd be looking at? If you could answer this, fantastic. If not, it's okay. Anybody have an idea? I mean, it's not, you got a picture where -2 is, and where do you think you'd look at on the unit circle? How many degrees? Anybody have a guess?
225.
You wanna give me 2 seconds?
Not 225. Oh wait, yes it is, yes it is. I was thinking -2, +2. Yes it is, definitely 225. Because I mean, where it is this. -2, -2 is this point right here, which splits this right in the middle, okay? Which is 225 degrees. Sorry about that, Bigelow. Yeah, so 225. But we're gonna pretend we don't know that. So the sine of theta, the cosine of theta, and the tangent of theta. Well, the sine, if we look at 225, is negative radical 2 over 2. Cosine is negative radical 2 over 2. Tangent is positive 1. Cotangent, secant, and cosecant. Flip 1, it stays 1. Flip radical 2 over 2, it's radical 2. Flip radical 2 over 2, it's radical 2, both negative. Now, if you didn't see that, you could still draw a picture and still figure them out. You could, okay? But since they're the same, it's splitting that quadrant into 2 equal parts. 89, I think it's the last one. Yes, it is. -3, -2. Okay, -3, -2. So, this is not on the unit circle. It's beyond the unit circle. We need to plot a point. So we go left 3, down 2, put a dot at 0, 0, connect them. So we have a dot at -3, -2, dot at 0, 0, connect them. And then we form our right triangle by connecting it to the x-axis by drawing a line up. So we draw a line up, and it's not just a triangle, it's a right triangle. This is -3, this is -2. Since both legs are negative, is my hypotenuse also going to be negative? Should we make that -2? Hypotenuse is always positive. It's always positive. There's a desk there. Okay, so A and B are -2 squared plus -3 squared is c squared or h squared or x squared or whatever variable you want to use. I don't care what you use. 2 squared is 4. 3 squared is 9. 4 and 9 is 13. So c is the square root of 13. So we label this the square root of 13. In our reference angle, again, it comes out of 0, 0, inside the triangle. So it's this little angle right there, okay? So we're trying to find the sine of that angle. So, sine, cosine, tangent, cotangent, secant, and cosecant. Okay, so we have to know SOHCAHTOA. Sine is opposite over hypotenuse. So here's theta. Opposite is negative 2 over 13. I'm sorry, over radical 13. Before I fix that, I'm going to flip that for cosecant. We're going to have radical 13 over negative 2. Now I'll go back here. Let's flip, or times the top and the bottom by radical 13. You do that, you're going to get negative 2 radical 13 over 13. For cosine, it's adjacent over hypotenuse. Adjacent is negative 3 over the hypotenuse is still radical 13. Again, I'm going to flip that right now to get secant. Radical 13 over negative 3. Go back to cosine times our radical 13. You're going to have negative 3 radical 13 over 13. And for tangent, it's opposite over adjacent. Opposite is negative 2. Adjacent is negative 3. I would probably take negative 2 over negative 3. I probably shouldn't, but I probably would take it. But a better answer of negative 2 over negative 3 is positive 2/3. And negative over negative is a positive, so the reciprocal for cotangent is 3/2. Okay, any questions on these? A lot of busy work on these, a lot of writing. Okay, so you have the rest of this hour to work on these, to fill in the evens. You have all day tomorrow to work on these, and then Monday we're going to have a homework quiz over this, okay? And also unit circle quiz on Tuesday for you guys, probably, yeah, Tuesday. All right, rest of the time's yours, guys.